everyone. Today I am going to tell how to find the domain of a square root function. The domain is the set of all real numbers which satisfy the given square root function. And we know that the real numbers are irrational and rational numbers. You can see here, these are rational numbers and these are irrational numbers. So real numbers include all irrational and rational numbers. So we cannot write all the real numbers, all the elements of the real numbers in the set. So we have to write the domain as an interval notation like this. This you have already learned in the sets chapter. This is open interval and this is closed interval. Open means excluding that value, and closed means that is including that value. And these are the examples of real numbers, including rational and irrational numbers. And then let us see some properties of the square root numbers. For example, if you see root 0 is equal to 0 and root 1 is equal to 1, like this, if you write any real number in the square root, you will get again the real number. So these are the defined values, 0, 1, 1.414, these are the defined values. But if you write any negative number like -4, -5, -13 like this, square root of -4 is undefined. If you write any negative number, that square root is undefined. So you should not write any negative number in the square root. So if you observe these examples, here the real number should be 0 or greater than 0. That means here if you see root x, then x is greater than or equal to 0. It is either 0 or greater than 0. So you can write x is greater than or equal to 0. This value in the square root compulsory, it is greater than or equal to 0. If you see some examples, then you will understand how to find the domain of the square root function. This is first problem. If f of x is equal to square root of x minus 2, then find the domain of this function. And here x minus 2, you have to substitute x values which satisfy this function. You have to find the x values that satisfy this function. So here it is in the square root, and this x minus 2 is greater than or equal to 0 because it should not be a negative number. It is in the square root, it should not be a negative number. And those x values are the domain of the this function. So x minus 2 is greater than or equal to 0 and x is greater than or equal to 2. That means it is including 2 also. You can show this on the number line like this. This is a number line, minus infinity, 0 and plus infinity. And it is a positive number. X is greater than or equal to 2 means all the x values are either 2 or greater than 2. So this is positive numbers you have to write here on this side, and it is including 2. So you have to show like this, and x values are from 2. So you have to show like this. There are infinite number of real numbers from 2. So you have to put plus infinity. So now the domain of this function is equal to, this is closed bracket 2 because this is including 2 comma infinity, and this is open bracket because here infinity is a symbol. It is not a number. That means the real numbers does not have an end. There are infinite numbers. So you have to show like this. You are excluding this symbol. So you have to show the domain like this. You can check less than 2 values. If you check, see -1, 0, 1, all are less than 2. If you apply those values, you will get undefined values. Therefore, x values are greater than or equal to 2. This is the domain of the function. If you see this example, f of x is equal to 1 by square root of x minus 2. In the previous case, f of x is equal to square root of x minus 2. But here it is in the denominator. So if it is square root of x minus 2, just check here. It should be greater than or equal to 0 because it is in the square root. But here it is in the denominator. It should be greater than 0. It should not be equal to 0 because in the denominator, the value should not be equal to 0. So here you have to use x minus 2 greater than 0. So see the domain here. Here it is including. 2 is including. But here you have to exclude 2. That's why you have to put the bracket, open bracket here. a closed bracket and you have to use open bracket. So see the difference here. If it is in the denominator, just you have to exclude the 2 value. That is the difference between from the previous case to this case. This is second one. If f of x is equal to square root of x plus 2, then find the domain of this function. See the difference between the previous one and this one. Here it is x minus 2. So x is greater than or equal to 2. And here x plus 2. So x plus 2 is greater than or equal to 0. Therefore, x is greater than or equal to minus 2. In the previous case, x is greater than or equal to 2. Positive number. Here minus 2. So here x values are either minus 2 or greater than minus 2. So you have to show like this. This is minus 2, negative number. And this is minus 1, 0 and positive numbers. So all these real numbers are the set of all these real numbers is the domain of this function. So you cannot write all these real numbers in the set. So you have to show like this. Domain of this function is equal to minus 2 because it is including comma infinity because greater than minus 2. So all positive numbers and from minus 2 to negative numbers. So you have to show like this. And you can check some values by applying x values and you can check like this. This is another one. If f of x is equal to square root of 2 minus x. In the previous case, it is x minus 2. So here 2 minus x. So 2 minus x is greater than or equal to 0. Therefore 2 is greater than or equal to x. Therefore x is less than or equal to 2 because 2 is greater than or equal to x, or you can write x is less than or equal to 2. So here all the x values are either 2 or less than 2. So you can show on the number line like this. So 2, this is positive number. And less than 2. So you have to write the values from here you have to write. So you can show the domain of this function is equal to, because here minus infinity, first you have to write minus infinity excluding open bracket. This is excluding minus infinity, comma 2 to 2. Because it is x is less than or equal to 2. So this is closed bracket because it is including 2 also. Is another type of problem. If f of x is equal to square root of 9 minus x square, here it is a square number. So 9 minus x square is greater than or equal to 0. Therefore 9 is greater than or equal to x square. Therefore x square is less than or equal to 9. Therefore x is less than or equal to square root of 9, that is plus or minus 3. If you square plus 3, then you will get 9. If you square minus 3 also, you will get 9. So x is less than or equal to plus or minus 3. Here in this case, you are getting two cases. See here, either x is less than or equal to plus 3 or x is less than or equal to minus 3. So you have to check whether these two cases are satisfying this function or not. For this, first write 9 minus x square is greater than or equal to 0. Here x square, here 9 minus x square. So you are subtracting x square from 9. So x square should be less than or equal to 9. Okay, so x should be from minus 3 to 3 because x should be less than or equal to 9. That means minus 3 square is 9, 3 square is also 9. So it should be less than or equal to 9. Then only this value is defined. And this you can show on the real number line like this. Here x less than or equal to plus 3. So from here to in this direction, and x less than or equal to minus 3. So from here to in this direction. But here if you take any number which is less than minus 3, that means if you take any number minus 4, then 9 minus 4 square, that is 9 minus 16, that is minus 7. So it is a negative number, so it is undefined. So you should not take less than minus 3 values. So here x is equal to minus 3 is okay, but x less than minus 3 we should not take. So cross here. Then you have to take the values from minus 3 to 3 only. So the domain of this function f is equal to minus 3 comma 3. These are the closed brackets because from minus 3 to 3. See here, if f of x is equal to 1 by square root of 9 minus x square, then here it is in the denominator. So you have to change the domain of f is equal to, here you have to put open bracket because here it is in the denominator. It should not be equal to 0. So you have to exclude these two numbers. So this is the difference between these two domains. This is another question. F of x is equal to square root of x square minus 9. In the previous case, it is 9 minus x square. So here x square minus 9. So here x square minus 9 is greater than or equal to 0. Therefore, x square is greater than or equal to 9. Therefore, is greater than or equal to plus or minus 3. In the previous case, x is less than or equal to plus or minus 3. Here, x is greater than or equal to plus or minus 3. So here there are two cases, x is greater than or equal to 3 or x is greater than or equal to minus 3. So you have to check these two cases whether these x values are satisfying this function or not. So if you see on the number line, here first x is greater than or equal to 3. So greater than or equal to 3 means you have to include 3 and greater than 3. So positive numbers from 3 you have to show like this. This is plus infinity and x is greater than or equal to minus 3. So from minus 3 and greater than minus 3. So you have to show like this, these numbers. But if you observe here, x square minus 9 is greater than or equal to 0. So here you are subtracting 9 from x square. So x square is greater than or equal to 9. Then only this function is defined. So x square should be greater than or equal to 9. If you check here, for example, if you take any number minus 2, because here it is given x is greater than minus 3. So minus 2 is greater than minus 3. So if you check minus 2 whole square minus 9, that is a negative number. This is a negative number. And if you check 0 also, 0 minus 9, that is also minus 9, that is a negative number. If you check any number here, 1. So that is also 1 square minus 9, that is also minus 8, that is negative number. So greater than minus 3 and less than minus 3. So from here the values are not satisfying this function. So here these values are not satisfying. If you check less than minus 3, for example, if you take minus 4, less than minus 3 is minus 4. Minus 4 whole square minus 9. That is 16 minus 9. So positive. If you take any number minus 5 in this direction, minus 5 whole square minus 10, that is also positive. So less than x less than minus 3, those values are satisfying this function. So here in this case, the domain of this function is minus infinity, comma, minus 3. Here it is excluding open bracket and it is including minus 3 is including. So you have to write these values and union 3 comma infinity. So you have to write this. That means here the x values are satisfying this case and this case also. So you have to put union. That means these values and these values, both values are satisfying this function. So the domain of this function is like this. Now, please do these practice questions. And these are the answers.